Welcome to Haskell, spelled the same way as Wordle, DLE. In this project, we set out to bring the strategic fun of Wordle to a functional programming environment in Haskell. I'm Daichi, and here's the rest of our team.
Hi, I'm Parsa.
Hey, I'm Gabriel.
And I'm Amar.
Before we jump into the demo, we just want to briefly acknowledge the resource we used. The GTK3 library for GUI, a random RO library for hint generation, and for background knowledge of code, we relied on Google, YouTube, ChatGPT, as well as Stack Overflow.
So the goal we proposed in our POC was to create a fun way for computer science students to study CS terms, which is why we wanted to make Wordle made for CS terms. The three main goals we had were creating a program that would handle reading and processing user input. We would implement a user-friendly feedback system, and we would have a game flow that prioritized user-friendliness and made our game fun to play. We decided to take it even further for the MVP though, and add on a fourth requirement, actually building the GUI to let our game run. Now we can show you guys that GUI. So over here, we have the GUI that you get from running stack run. As you can see, I've already used up 5 out of my 6 guesses. We have a feedback system here that makes it easy for users to know what's happened. Green says I got the right letter at the right position. Yellow says I have the right letter, but in the wrong position. And gray says I have it completely wrong. So I have one more guess left. Let me get a hint to see what's happening. It tells me the first letter is J, and that I'm a widely used program language for building websites. Oh, I know. It's Java. Yay, I got it right. And now if I wanted to, I could start a new game where I see I have another easy word. Lucky me. Now let's talk about what's actually going on under the hood. One of the things we did was actually keep the game logic that we had from our POC that checks the target word against the guess and provides feedback. The one thing we changed was the actual feedback, making them colors so it was more user-friendly. Now Amar will talk about how we actually load in the game logic to decide the word and its difficulty.
New to the MVP, we use randomization to generate the word. The randomization sources words located in a text file, parses each line to extract the word and its difficulty, and chooses a word when the program is run.
Awesome. Thanks, Amar. Now let's talk about what's happening with our GUI. After we load the target word, we have to actually build our GUI app. And the thing with Haskell GUI building is that it's hierarchical in nature. So we build a window, we then add a vertical box inside our window. We create grids where we add different aspects of our GUI, and then we start populating it, such as putting the underscores for the positions of the letter, the submit button, and the hint button. Over here, you can find our main game logic and what actually happens when you press a button. So by attaching an event listener to the submit button, whenever the submit button is pressed, all the logic in here is activated, such as checking if you've used up all your guesses, or providing you feedback. Now Gabriel will touch more on how the hint system works.
So for the hint system, we actually used the dictionary that was mapping the target words as keys and the riddles associated with them as values. And then we used a helper function that was dealing with exceptions, such as when a word was not found, and always returning a correct string to the user as feedback.
The other hint logic relies on 2 key concepts: randomization and state management. In the random RO library, we generate a random index to reveal a letter from the target word. For state management, we utilized IORef to handle GUI states like hint counters while maintaining Haskell's functional purity. Lastly, the new game button lets players start a new game by resetting the interface and generating a fresh word. Similar to Amar's explanation, we used read file to load and process the word bank file. And to ensure unpredictability, we again used random RIO library to pick a random index for a new word, and then finally recalling the launch GUI method with a word and its difficulty.
We had a lot of fun working on this project and hope you enjoy playing it.
Thanks.